Hello, everyone. Thank you for joining this session. I see some familiar faces, and it's nice to be around friends here. Welcome. So today we're going to talk about how we can make actually reliable AI agents, and I'll try to share some tips with you, and hope some of them will resonate with you. First, a little about me. My name is Bilge. I work as a developer relations engineer at deepset for over 3 years now. I used to live in Istanbul. I'm originally from Istanbul, but in the beginning of this summer, I moved to Berlin. People tell that it's the best time to move to Berlin, and I would agree. So if you ever want to move to Berlin, do it in the beginning of summer. I am in social media. I use Twitter, but more LinkedIn. So if you like to connect, you can add me on those platforms. And a little bit about context about the company that I work for. It's called deepset. It's based in Berlin, and it's actually founded in 2018. So for over 7 years, we are helping big enterprises like Airbus, Siemens, Bosch with their custom AI solutions. And at deepset, we have 2 products. Haystack, our open source LLM or AI orchestration framework, and deepset AI platform. This is the enterprise product that we have, and this is actually how we make money if you have any questions around that. We will be mostly talking about Haystack today, so you'll learn about it later. And everything that I will be sharing in this presentation will be behind this QR code. Don't worry about it now. I'll just put it here for you to keep that in mind. In the end of the presentation, I'll share it with you already, so keep your phones ready if you want to get materials. All right, now I want to learn a little bit about you and where you are at your agent journey. So how many of you have worked with agents and deployed them into production and have a running agent in production? I see 10 hands tops, which is a very low percentage, I would say. All right, and how many of you have worked with agents but nothing in production yet? Okay, now we go to 30%. How many of you are learning about agents now, maybe starting in 2025? Maybe this is your first presentation around agents. Can I say the rest of the people? Yeah. All right. Okay, it's nice because probably everybody will get something out of this presentation. All right. I think we should start with a definition of what an AI agent is. Everybody would come up with a different definition. There is no one consensus around this, but this is my own definition. I would define an AI agent as an LLM-based system that autonomously pursues a goal by interacting with its environment using tools. You'll see 3 underlined words there, phrases there, and I think these are the most important ones. They need to be LLM-based. I mean, of course, agents go back before the LLMs, but now, the modern AI agents needs to be LLM-based systems. They need to be able to interact with the environment, understand what's happening there, and they should be able to change it. And they should be able to do that using tools. So these are the 3 important things. But I'm not here to tell you about the agents. I'm here to tell you about why they fail and how we can fix that. And here's an example. Here's a code. This is my favorite code, and it's from a community member in Haystack. So not a famous person. And it goes agent involves a lot more work than expected, and 90% of it's pure engineering. Nothing really to do with an LLM, but it's how to blend LLM into an agentic workflow that makes sense. And I would actually agree with this quote because in the end, yes, we are working with AI applications, we are working with LLMs, but in the end, we are working for these big systems. And when it comes to these systems, you need to think as an engineer. And LLMs, AI, I would say they are a part of it, but not the whole thing. How many of you would agree with this quote? Okay, yeah, okay, nice to see that, great. And I think this is one of the reasons why most of the agents fail, because we trust too much on the LLMs, but we don't worry enough for the design of it. Yes, our prompts might be brittle, we might be giving too many prompts to our agents, to our LLMs, but we also don't think about the fallback plans. What if our LLMs fail? What if there is an issue in our system? And we don't think about observability as we are building the system. Yes, maybe we are using observability tool for the whole system, but what are we using to observe our agent, to observe these tool calls, the responses coming from the tools? And the last part is the guardrails. Yes, if we need to have the control of the inputs coming to our system and the outputs going out of the system. And these are, I would say, the main things that we ignore when we are building with LLMs. And I would say that the second reason why most of the agents fail is because it's the wrong use case for the agent. I know the 2025 is a year of agents, but not every system, not every use case need to have an agent in there. If you have a complex multi-step problems requiring diverse actions, if your task involve of course, multiple tools and sources like deep research agents, yes, go with your agent architecture. I have nothing against that. So basically, if the goals are clear, but the optimal path is not determined, agent might be the right architecture for you. But on the other hand, if when interactions for your use case can follow a predictable pattern like question answering, RAG, or maybe data ingestion, if the task can be decomposed into clear steps, maybe you don't need an agent. Yes, you don't need to have an agent to make things more complex in your system. And also another reason why you might not want to use an agent is if you value stability, robustness, and efficiency over automation, then yes, you need to go with the pipeline, with the AI workflow, whatever you want to call it. So, and as an engineer, as a developer of the system, this should be your call. And I have a small tip here. If your system needs reasoning, go for the agent. And if your system has defined flows and you know the path to the solution, then pipeline workflow might be a better fit for you. But of course, this decision doesn't need to be black and white. I would say the AI workflows and AI agents, they are in a spectrum. So you can come up with the optimal, the sweet spot and find the right amount of autonomy in your system. Because in higher autonomy, yes, you are able to solve more complex problems, but you are also introduced with higher risks. What happens if the wrong tool is picked, if there's a problem and it's hard to debug it. So the ideal thing I would say is to blend them two and basically give some sort of autonomy to your system, but keep the rest of the things as deterministic as possible so you have more control over the system. So with that approach, you can maybe sacrifice from the performance a bit, but you would gain speed and you will save a lot from the cost. Okay, then after learning some of the reasons why these agents fail, let's talk about how we can design more reliable agents, more reliable agentic systems. And here I will be talking a little bit about Haystack, and this is my introduction slide to Haystack. Haystack is an open source AI orchestration framework by deepset, and it's actually the backbone of the AI platform that we offer for our enterprise customers. Haystack provides the tools that Python developers need to build real-world agentic AI systems with visibility, control, and modularity. And I think these three characteristics are really important when you want to go with an AI framework in 2025. And this flexibility, this modularity comes through the building blocks of Haystack. In Haystack, there are two main ones, components and pipelines. Components are the smaller unit. They only have one responsibility, like generating text, generating embeddings, maybe retrieving relevant information, doing some sort of classification, some sort of evaluation. So basically, you design the component or just select from the list of components that we have in Haystack. And by connecting components to each other, you form pipelines. And pipelines are directed cyclic graphs, which means that you can, yes, have a defined flow, but this defined flow doesn't need to be sequential. So you can have branches, you can branch out, you can merge those branches, and you can even have loops, some sort of like they are quite useful when you want to have some sort of retry mechanism in your system. And if you are not very fond of graphs and like the pipelines, you can go with the Haystack agents. And Haystack agent, like agent component in Haystack, is a component that just gets an LLM, and this LLM can be from any provider, like OpenAI, Anthropic, Google, or open-weight models out there. Then you need to provide a system prompt because your LLM needs to know how it should behave. And then you need to provide a list of tools, or like how many number of tools that you want to give. And tools in Haystack can be Python functions, external APIs, Haystack components, and MCP servers, if you will. But the good thing with Haystack agents is that they are also component. If you remember this, as a component, you can put a Haystack agent into your pipeline. And what does it mean? It means that you can find the optimal level of autonomy in your system. And here's an example. This is a real-life GitHub issue resolver agent that we implemented with Haystack, and this is the architecture of it, I will say. You see, like it's a pipeline. The green ones, the green boxes are the components in this pipeline, and they are very sequential. So this agent accepts an issue URL. And the first component, GitHub Issue Viewer component, retrieves the issue description, issue title, and issue comments from the URL. The second component, GitHub Issue Builder, renders a prompt for you by taking like this information from GitHub. And the third component is actually an agent. So it's autonomous on its own, but when you look at it to the bigger picture, it's actually a part of a bigger process, and the first part of this process is actually deterministic. And this agent, what this agent does is that it gets this prompt with the issue information, it goes through the repo, goes through the files to understand like what is the problem here and how I can solve it by iterating over the repo a couple of times, by going over the files. And then when it's done with the solution, it just posts the comment to the same issue. And you see that's why there are like two tools connected to this agent. And in the end, I end up with a comment that includes like all the information that I need to resolve that issue. It's quite handy because if you're working with an open source library like Haystack, we are the maintainers of Haystack, it comes very handy because now we at least know how we need to solve that issue without like going through the repo every time. And if I can, let me show you actually one of the examples here. So here's an issue that I opened. It's in my fork repository, so it's not in Haystack because I didn't want to mess up with the issues there. But what I asked my agent to do is actually, like in the agent component, there are different parameters. It's basically a Python class with different parameters. But I want this print streaming chunk is to be the default value for one of the parameters. So we have the streaming callback parameter to support streaming in Haystack. And I want this print streaming chunk that is in this URL, in this file, to be the default value. And what this agent does is that it goes through the repo multiple times, and it first understands the current implementation. It tells me that like the streaming callback, there's like nothing set there, and I need to change it with this print streaming chunk. And as it proposes a change, so it tells me that instead of like here, instead of setting this to none, print streaming chunk should be here, and it even puts the import line for me. And actually, this is something that I didn't ask, but what it did also is it updated the serialization logic. So when you are working with Haystack components, you need to serialize and deserialize them. So it understood that, okay, this is a common pattern for every component, so we need to keep that in mind and do that. And here it updates the serialization logic and deserialization logic, and it tells me a bit about the benefit. Like it tells me that this change provides a better UX for debugging and transparency, and it's backward compatible. But as a consideration, it also tells me that like users, they used to have this non-value, now that's going to change. And it also tells me that I need to put it in my release notes. As a developer relations engineer, this is also very useful for me. All right, let's go back to the presentation. All right, yeah. And another thing that you can achieve with this approach is splitting the task. Basically, you can add another agent right after this whole system, and this time you can ask this agent to open the PR for you because you already have the plan. The other agent, this issue resolver agent, had already planned everything for you. It provided like the changes, how they should be done, and the rest is just the PR agent can just go to the repo, find the relevant files, and open the PR for you. And if you just connect the MCP server of GitHub, probably you can like achieve it even today. And in the end, with this approach, I will end up with a new pull request instead of just a comment in my issue. And the previous architecture and this architecture is actually built by our team, so you can find it in the cookbooks that you will also get the link in after the presentation. And I think the other part of like building reliable agents is observability. I have been talking about this a lot in this presentation, but it gives you insights on what's happening inside your agentic system. So when you have this modular system, yes, you can see what's coming to your component, what's going out of your component, but you also need to be able to see what's happening inside this autonomous agent. And if everything goes well, yes, you think that you don't need that, but it can be also useful to detect hallucinations. So basically, the input might feel real, but in the end, maybe it's just like fake information. And I actually have the tracing for this very GitHub issue resolver agent. I like using like open source tools for observability as well. LangFuse is one of them. And you can basically connect your Haystack architecture, Haystack pipeline to LangFuse by just providing credentials. And here what you can see is like if you go to this trace, you see like there are 3 components here. Issue weaver, issue builder, just like as I showed you, and issue resolver agent. And here you see like this agent runs a couple of times, calls this repo weaver tool a couple of times to explore the repository, to understand what was happening and how it can fix the issue. And in the end, it sends the issue to GitHub. All right, let's go back here. Okay, now it's time for another demo. This is just our another agent. It's Itinerary agent built with again Haystack. This is just in production, so you're gonna be the first ones that are gonna experience this agent in production. So let's go ahead and check that. So it has this UI. And through this agent, I want to explain also some of the principles that you need to keep that in mind when you're designing the agent. So what this agent does is it plans the trip that you want to take for you. And here is there are some suggested prompts. For example, weekend in Barcelona. So you can ask this agent to plan a 2-day weekend trip to Barcelona, focusing on architecture and tapas. You can tell it to find 4-star hotels for you. Do it in a very optimal budget and through public transport. And you can also name some of the places that you want to go, like Sagrada Familia or the beach. And you can enter this, but it takes some time because there are multiple agents working in the system. One agent is responsible for coming up with ideas and through Perplexity. The other one is finding the optimal route between all of the places that we mentioned here. The other one is trying to find the good places that you can go in Barcelona. And the other one is finding good architecture, where you can find good architecture. So a lot of planning, a lot of thinking, a lot of research is involved. That's why there are many tool calls involved here. This takes around 2 minutes, so I don't want you to wait that much. That's why I ran this already. And after running the tools multiple times and planning daily itinerary, of course. You end up with a long output, but you'll find everything here. Like in day 1, it tells me to like check into the hotel. It even gives me the exact location of the hotel, some maybe tips. It tells me where to go between, like in the morning, then where to go in later, and how I can even go between those places. So it is really handy if you want to like plan your trip. And in order to access to this demo, it's in itinerary-agent.deepset.ai. You just need to connect your GitHub account to it. It's because of the OpenWeb UI requirements, so nothing that we would fancy, but OpenWeb UI is asking for this information. Something that I want to like show you here is that if you go to this one, as a user, yes, I know something is happening behind the scenes. Since I'm a developer using this, it's useful for me to know like which arguments were sent to this tool and which response I got from that tool. So it's useful information for me, especially if something goes wrong. But as a user, it's also useful because then you know that your system is not giving an error, because you know like there's some progress happening in your system. And what I can do next here is that I can maybe try to ask it about the weather. So how is the weather in Barcelona right now? And this time my agent returns that no, it violates our usage policy. So just ask me questions about like traveling and itinerary, because other questions I don't want to answer. That's nice, because now I know that my users wouldn't exploit this this agent. And what I can do next is maybe make this trip for 500 days. Again, no, it tells you no, because otherwise I would run out of tokens, and probably it would take, I don't know how many hours to generate a response for that. And this is a good, of course you can come up with better guardrails here, but this is definitely one of the things that you need to keep that in mind when you're designing this system. All right. Okay, now let's sum all of this up. So here are all the things that I talked about and I would talk about if I had more time. So tips that I have. Find the optimal level of autonomy for your system and have the control. Make some part of the system deterministic so that nothing goes out of your hands. Minimize the number of tools that you provide to your agent. So each new tool adds a failure risk. Especially when you are working with MCP servers, don't just connect the MCP server right away. Pick the relevant tools for your system and only have those tools provided to your agent. If you can, split the agents, create multi-agent systems. So instead of just giving, I don't know, like 10 tools to one agent, split that responsibility into 2 agents and give 5 tools to each. Build fat tools. This is a part of the fallback mechanism. So instead of trying to handle the errors on the agent level, build tools in a sense that they handle their own errors, so your agent don't need to deal with everything, because they already have too much to think about. Build guardrails, validate your inputs, your outputs, everything happening in your system. Log everything. When everything goes good, you think that you don't need them, your system works, but they are quite handy if your system fails. And if you're working with, I don't know, healthcare systems in this very delicate areas, try to have human in the loop and let people oversee and guide the agents. And here are some of the sources that I have for you to help how to build such agents. And as the last, we just launched a course on DataCamp, Building AI Agents with Haystack, where I tell you step by step all of these principles and show you how you can build all of them in Haystack. So that was it. Thank you for listening. yes, right now it's the time to scan this QR code if you want to get the materials. Just fill in the form, then you'll get a very friendly email from me with all of the links and the presentation. If you want to go and check out the itinerary agent, you can do so in the itinerary-agent.deepset.ai. You also see the link there. And yeah, again, thank you for joining, and hope to see you next time. Bye.
Thank you very much. Thank you very much for this presentation. We actually have one question, and this is, what are the advantages of using Haystack for building agents over the other seemingly more widespread options like LangChain, LangGraph, DSPY?
Several reasons. I like saying this, but we were doing NLP before it was cool. So Haystack is actually a pretty old framework. It started around 2020. So back then, the fanciest thing that you could do was, I think, extractive question answering. And we were already working with lots of customers around this use case. Now, of course, the field has changed, and now we updated the Haystack architecture as well. But we have lots of experience in the field. And if you look at it from the architecture perspective, I would say that there's a long list of components that comes in Haystack. So you can already build your system today with Haystack. But if there's a custom thing, like custom logic that you want to incorporate into your system, or maybe there's a very special tool that you use internally at your organization, you can just create your custom component and put it into your pipeline. And another thing, and people tell this a lot, we have great documentation and backward compatibility. If you go to Haystack website, you can see the documentation there. Everything is very well documented, and we make sure that the breaking changes don't happen that much, and if they happen, you're gonna learn about them, and everything is gonna work smoothly.
Thank you very much for that. The great documentation is also very welcome. One more. Yeah. We have actually one more question. So, do you benchmark your multi-agent solutions over existing LLMs? Travel planning works quite good with the existing LLMs already, for example.
We haven't tested that many LLMs for this one. Probably this is our first prototype right now. Maybe after some time we'll come up with different solutions. Right now it uses GPT 4.1. That's the best, probably cost-wise and the performance-wise, the best model that we could use. But yeah, maybe in the future we'll try with other open source models and see how they perform in the system. But I think first we need to hit this cost limit to start thinking about other options.
Yep, thank you very much. That was all the question, unless there is some from the audience, since we have 2 more minutes.
Nice and elaborate demo. So I wanted to ask maybe, how do you monetize your product? So it's usually very difficult and tough to go forward with an open source and some open library. So I wonder, how do you establish that you can continue with your mission?
I'm sorry, can you repeat the last part of the question?
Yeah, so the question was actually about monetization. So how is Haystack monetized and supported?
Oh yeah. That's a great question. So actually at deepset, Haystack is our open source framework. This is how Haystack actually started. But we have our enterprise solution that uses Haystack as the backend, but it comes with the UI as the whole platform, where you don't really need to think about how to host the model, how to host your where to keep your data, etc. So we help you with all of that, and it also comes with the support with the service. So this is how we monetize this whole system. But if you want to use Haystack for your organization, it's completely open source. Nothing is hidden there. You can go ahead and build whatever you want. Even build your own I don't know, deepset 2 AI platform and monetize it. That's completely fine by us. So yeah, that would be the short answer to that question. Yeah.
Thank you very much. So please, warm round of applause for the speaker. Thank you very much.